So in problem number 5, it says the function g is defined and differentiable on the closed interval from -7 to 5, and g of 0 is 5. The graph of y equals derivative of g of x is up here. So this is the graph of the derivative. We need to keep that in mind. Derivative of g consists of a semicircle and 3 line segments that's shown. Well, our first part here is actually similar to what we were just doing, but has a little different twist to it. We want to figure out what g of 3 is. Well, g of 3, we know what g of 0 is, but we don't have like an original function for g, an equation that we can just plug in. We don't have the graph of g that we can just look at. So we have to use that technique we just learned using fundamental theorem of calculus. So g of 3 is going to be the same as g of 0 plus the change in g from 0 to 3. Right, so we're taking the definite integral of the derivative of g from 0 to 3. That gives us the total change. So g of 0 we know is 5. Now, in the earlier problems, we had an equation. We could plug it in our calculator and figure out this definite integral. Now we're dealing with a graph instead of an equation. So how do we figure out the definite integral from 0 to 3 of the derivative of g of x?
You find the area between
Area under the graph from 0 to 3, right?
Yeah.
So we're going to find the area under the graph from 0 to 3. So that's going to consist of this quarter circle and then a triangle. Right, that is right here. Right? That definite integral is represented by the area under that curve. So for this, what's the area of a circle? Pi r squared. So our radius here is 2, so the area of the full circle would be 4 pi. What's the area of this little part going to be then?
pi.
Just pi. Right? It's 1/4 of the whole circle, so if we take 4 pi divided by 4, the area of this is going to be pi. This area, we just have a triangle, 1/2. Our base, careful, our base is just 1. This is going from 2 to 3. And so our base is 1, height is 3. So our area for that is 3/2. So it's not going to be a very pretty looking answer, but we have 5 plus, this whole thing is pi plus 3/2. Oops. So we can combine like terms. We can add the 5 and 3/2. So this is like 10/2 plus 3/2. So we get 13/2 plus pi. It also asks us to find g of -2. So g of -2, that's going to be g of 0 plus the definite integral from 0 to -2 of the derivative of g of x dx. So g of -2 equals 5 plus area under the curve here, but I'm going to switch it around here. Like I said earlier, when you're doing it in your calculator, it really doesn't matter. Here, it helps to kind of keep things straight. Switch this around so that we have the lower value on the bottom. So we're going to go from -2 to 0. So we need to find the area under the curve from -2 to 0. Well, that's just going to be pi, right? That has the same area as that other quarter circle. So our answer for this one is going to be 5 minus pi.